Good morning, Algebra 2 students. It's Tuesday, September 1st, and I couldn't make it today to be with you, so I did a little video here to go over section 1.4 with you to get you ready for that. And then tomorrow I'll be back and we'll do a practice quiz over the first 4 sections of chapter 1 for our assignment. Thursday we'll go over that, and then Friday we will have our first quiz. So just for a warm-up here today, think about some words that mean addition. So I'll just pull the slide down, the screen down. Sum and total are words that would work for addition, and then for multiplication. Times, multiplied by, product. Sum and product are the ones you'll see a lot. Total you'll see a lot too for addition. So you're going to start doing a few reading some math problems or some word problems and have to translate it into an equation with addition, subtraction, multiplication, or division. The next number 3, it says just evaluate 3x for x equals 2. That 3x, remember, means 3 times x, so 3 times 2 would be 6. For number 4, we're substituting 7 in, so we got 5 times 7 minus 4 minus 3 times 7. So 5 times 7 would be 35. Minus 4 and 3 times 7 minus 21. So 31 minus 21, that would be 10. And then simplifying expressions, we'll just go 3 times 2x, will be 6x, and distribute the 4, so you have 4x plus 4y. Things you probably already know, but just to get us warmed up for some of the stuff we're going to look at today. So we're going to simplify and evaluate algebraic expressions today. That's our objective. And so we'll look at some mathematical expressions. There are 3 different ways in which a basketball player can score points during a game. There are 1-point free throws. That should have been right up there with it. 2-point field goals and 3-point field goals. An algebraic expression can represent the total points scored during a game by F plus 2G plus 3T. So F represented free throws, and G represented field goals, and T represented 3-point field goals. So that was just an example of an algebraic expression. So to translate a real word situation into an algebraic expression, we must first determine the action being described, then choose the operation that is indicated by the type of action and the context clues. So if you're combining stuff, you're adding stuff, context clues could be how many total. If you're combining groups, you're multiplying how many all together. You're going to separate stuff, you're going to subtract things, how many more or how many remaining. Separate into equal groups, that's division, how many in each group. So you're going to have to pay attention to context clues to figure out if you're going to add, multiply, subtract, or divide. So here's a situation. The number of apples in a basket of 12 after n more are added. All right, so we're adding n apples to 12 in the basket. So we can write 12 plus n. Another situation, the number of days it will take to walk 100 miles if you walk m miles per day. So what I like to tell students when you have this type of problem and they're throwing letters at you is that you could plug any number you want in for the letter or the variable, and then usually you know what to do to figure it out. So if we walked 5 miles per day, how long it would take us to walk 100 miles. Well, most of you would know automatically right away that you would divide 100 by 5, and it would take us 20 days. So we go back and put m in for miles, and we would just write 100 divided by m for that algebraic expression. Lucy's age, Y years after her 18th birthday. So after her 18th birthday, Y years after, you're adding on to it. So that would be 18 plus Y. The number of seconds in H hours. All right, so here you got to think a little bit. You know, we know how many minutes in an hour, but then we're talking seconds. So we have to think of 60 minutes in an hour and 60 seconds in a minute. So we're going to have to multiply by 60 twice, or 60 times 60, or 3,600. So 3,600 times H. So, 5 hours, you'd go 3,600 times 5 to see how many seconds that would be. All right, order of operations, you know this. You've heard, please excuse my dear Aunt Sally. Some of you say PEMDAS, but here are the order of operations. Parentheses and grouping symbols first. P for please, P for parentheses. Excuse goes with the exponents. Whenever you have exponents, you do those next. And then my dear Aunt Sally, my dear, well, is for multiplication and division, but remember, you go left to right, like you're reading a book. Sometimes you'll divide before you multiply. And then Aunt Sally, or AS, for add, subtract, again, left to right. Usually what I do when I'm just having addition and subtraction is I'll look at all the positive numbers, add them, all the negative numbers, add them, and then subtract. They're at the very end. So evaluate this expression for the given values of the variable. So we're going to substitute 5 in for X and 2 in for Y, wherever we see those. So that's what they did. And then we're going to follow our order of operations. So we're going to do, there's no parentheses, nothing I can do in the parentheses. I just have numbers. There's no exponents. So I'm going to multiply from X. I'm going to 2 times 5, 5 times 2, and 4 times 2. And then 10 minus 10 is 0, plus 8 would be 8. Again, you could plug all that in your calculator if you want. Calculator knows the order of operations. And on your graphing calculator and your scientific ones, you have parentheses you can use. Okay, you look at the graphing one. Above the 8 and the 9 are the parentheses. So hopefully you're thinking about getting that graphing calculator soon. We will be using it in the near future. All right, so we got Q's and R's this time. So wherever we see an R, we're going to substitute 3. Wherever we see a Q, we substitute the 7. Now we have some exponents we have to do first. So 7 squared and 3 squared are 49 and 9. And then do the multiplication, 4 times 7 times 3, which is 84. And then 49 plus 84 minus 9 would be 124, I think. Yeah, 124. Again, you could put that all in your calculator. I would just put parentheses around where you put Q's and your R's and the numbers when you substitute. All right, again, in that same type of problem, we're putting 2 in for X, 5 in for Y. We're going to do the exponent, so 2 squared gives us 4. 5 squared gives us the 25. And then we'll do multiplication, 4 times 5, 2 times 25, 3 times 5, 20 minus 50 plus 15. So we get negative 30 plus 15, which would be negative 15. Okay, stuff you guys can handle. It's simple, you can do it, no problem. All right, so like terms. Recall that terms of an algebraic expression are separated by addition and subtraction symbols Like terms have the same variables raised to the same exponents. Constant terms are like terms that always have the same value. So we've got the like terms, the 3x squared and the 4x squared. The red ones and the blue ones are called constants when they don't have any variables, and they're like terms. It's like you first learned to add and subtract. So I would add the 3x squared and the 4x squared and get 7x squared. And there's only the one xy, so minus 9xy. And then 2 minus 1 would be plus 1. So we just simplified that algebraic expression by combining the like terms. So just giving you the directions or the procedure we use, combine like terms by either adding or subtracting their coefficients. Algebraic expressions are equivalent if they contain exactly the same terms when simplified. Terms that are written without a coefficient have an understood coefficient of 1. So x squared is the same as 1x squared. So in this example, the 3x squared and the 4x squared are like terms. I can put those together. They made them red. So that's 7x squared. The other two are not like terms, so that's our answer. And again, it doesn't really matter what order you have those. I like to put the variables with the higher exponents first and then down to the constant if there's a constant. Another one, we got to distribute first here. We're going to go j times the 6k squared and the 7k, and then we're going to combine like terms. So j times 6k squared is 6jk squared, and j times 7k is 7jk. And then you notice that we have like terms. The blue ones are additive inverses. They're opposites. They will cancel each other out. And then 6 plus 9 would be 15jk squared. Here we're going to distribute the negative 3 first. Negative 3 times 2x is negative 6x. Negative 3 times a negative xy is positive 3xy. Pay attention to your signs. Negative 3 times a positive 3y is negative 9y. And then minus 11xy. And as you can see, we have the red 3xy and the negative 11xy, which is negative 8xy. Again, this basic Algebra 1 stuff that you guys learned as freshmen, just reviewing it, getting you prepared as we'll go on a little further into our Algebra 2 class. So it says apples cost $2 per pound and grapes cost $3 per pound. Write a simplifying expression for the total cost if you buy 10 pounds of apples and grapes combined. All right, so they want you to write a single algebraic expression. So you need to make sure you're using a single variable. You can't use A for apples and G for grapes. So if you have 10 pounds of apples and grapes combined, that's 10 total. That means you could be, 1 pound of apples and 9 pounds of grapes, or 2 pounds of apples and 8 pounds of grapes. All right. So what I did, or what they did, is they let A be the number of apples, pounds of apples. So again, if I said that A was 3, you could tell me right away that the number of pounds of grapes would be 7. You'd go 10 minus 3 right away. So what you're going to do is represent the number of pounds of grapes as 10 minus A as the number of grapes. That's where some kids get confused. So again, if you're not sure what to do, plug a number in for A, and right away you'll know what to do to find the number of pounds of grapes. So it's $2 a pound for apples. That's where the 2 came for in front of the A, came from in front of the A, and the 3 pounds for $3 a pound for grapes, so that's where the 3 came from. And what they did is distribute the 3 to get the 30 minus 3a, and then combine like terms. So the expression that would figure out the total cost would be 30 minus a. So if you had, 4 pounds of apples, 30 minus 4 would be 26. That would be $26 is how much you'd have to pay. And then they just did that for you. I went ahead of myself there. So $28, and if you had 2 pounds of apples. All right, same type of deal here. A travel agent is selling 100 discount packages, makes $50 for each Hawaii package, $80 for each Cancun package. Right expression represents the total the agent will make selling a combination of the 2 packages. So let's move this down a little bit so you can see it. So they said let H be the number of Hawaii packages. He's got 100 total, so the remaining, the Cancun packages is 100 minus H, just like the last problem. All right, $50 he makes for Hawaii, so that's where the 50 times H comes for, and 80 for the Cancun, so that's where the 80 in front of the 100 minus H. Distribute the 80, you get 50H plus 8,000 minus 80H. Combine like terms, you get 8,000 minus 30H to figure out how much money he'd make. So they give you a 28 for the number of Hawaii packages for H, so you plug in 28, and that's 8,000 minus 840. So he makes $7,160. He sells 28 Hawaii packages. So that's basically it. Here's a little lesson quiz. You guys can do that quick if you want. You don't have to. But, work on the assignment the rest of the period. It's not that much. You should be able to get it done before you leave. Don't give Miss Burt a hard time. She will help you the best she can. Thanks for your attention. And again, Wednesday, we'll go over this homework assignment together. I'll give you the practice quiz. You can have the rest of the period to work on the practice quiz. Hopefully get done with that before you leave. And then we'll go over that Thursday in class. And then Friday will be your quiz. So you have a great day, and I will see you tomorrow.